Hey guys, welcome to another lecture from Introductory Statistics. Let's get back to what we were working on academically. So, we were working on probability distributions, and the last thing that we worked on was expectation of a random variable x. Today, let's talk about variance of x. What do we mean by variance? Why do we have this concept? Okay, so let's start with a couple of examples out here. Suppose you have two probability distribution given to us like this. So x is your random variable. In this case, x is taking three values, 3, 4, 5, and following other probabilities, 1 by 4, 2 by 4, 1 by 4. Hence, the mean turns out to be 4. On the right hand side, the example that you see here, x is taking 4 values, 1, 2, 6, 8. And following other probabilities, 0.4, 0.1, 0.3, 0.2. Okay. And if you calculate the mean of this probability distribution, that is also 4. So mean is 4 here, mean is 4 here. In case, imagine a situation, you were only given that a random variable x has its mean as 4. Would you be able to tell yourself what kind of distribution it would be? What kind of values would x be taking? Just with the knowledge of mu, we cannot say that, okay, x must be taking values 3, 4, 5, or x must be taking values 1, 2, 6, 8. So, mean doesn't tell you anything about the values of x. Mean doesn't tell you anything about how dispersed the values can be. For example, here the values are very close to each other, 3, 4, 5. But here, if you see 1, 2, and then 6, 8, dispersed, the values are dispersed, right? So, that's the concept of variability. Variability is talking about how varied is my distribution, how varied are the values that this random variable is taking from its mean value. That is what is the concept of dispersion or variance. We use variance as a measure to assess this variability. What are we looking at? We are looking at how dispersed, how varied are the values from the mean. So variance is what we use. Let x have PMF, Px and expected value mu. Then the variance of x, which is denoted as this sigma square. It's a squared measure that we take. Sometimes you write the x for the variable here as a subscript. Sometimes you don't need to do that. It is denoted as expected value of x minus mu square. Basically, you're looking at how varied is x from the mean. So that is denoted by x minus mu. But we take a squared version. That's why you have sigma square also denoting that. We take a squared measure. Okay, squared measure helps us in certain things. And we are trying to see this on an average how dispersed it is. And that is why expected value comes into play. So this becomes, by the concept of expected value, this is nothing but summation x minus mu square px, and it is summed over all the x's. The way you find expectation, you now have to find out expectation of x minus mu square. So what are we doing here? We are taking the squared variability here. So basically sigma square or variance is expected squared deviation. So this tells us that if, x's are quite close to each other, quite close to the mean, then the variability or sigma square would be relatively much smaller. And in case they are very far from each other, far from the mean, then sigma square will turn out to be big. Now, one thing is very interesting for sigma square. This formula of sigma square, which is that we have expected value of x minus mu square. This has a shortcut formula as well. So when you have to calculate sigma square, what do? You take the expectation of x square, ex square, and subtract the expected value of x square. So basically your sigma square is ex square minus mu square. So this is a shortcut formula, but how do we derive it? Let's prove it. So what we are working on is expected value of x minus mu square. Now x minus mu square could be open up as x square minus 2 mu x plus mu square, right? Now this means if I want expectation of x minus mu square, it is same as summation x minus mu square into px. Now I've just opened up x minus mu square for you. So it is summation x square minus 2 mu x plus mu square into px. Now with the summations, what happens? You can open this up. So this becomes summation x square px. Don't forget the weight attached is px minus summation 2 mu x px plus summation mu square px. So this is summed over all the x's, x square px. I'm going to keep it right now just like this, minus 2 mu is just a constant value. Mu is a number. It can come out here. So 2 mu here, x px here, summed over all the x's, plus again mu square is also just a value that can come out of the summation into summation px. Now think about it. Your summation px is sum of all the probabilities. Sum of all the probabilities is 1. So that means you just get mu square from here, right? Now summation x px summed over all the x's is nothing but mu. So you had minus 2 mu, and with this summation you get another mu. Now this expression that you have is nothing but the expected value of x square, isn't it? Summation x square px is expected value of x square. So what do you get here? Expected value of x square minus mu square plus mu square, which means expected value of x square minus mu square. So this is the shortcut that you always have to use while finding out the variance for any given probability distribution, probability mass function. Okay, let's take up an example. For example, if suppose I give you a probability mass function with the following values. P1 is 0.3, P2 is 0.25, P3 is 0.15, P4 is 0.05, P5 is 0.10, P6 is 0.15. So first of all, if you line it up, so in order to find out the mean, what you would do, you would find out x into px and then add it up. Well, mu will turn out to be, I've already calculated for you, 2.85. Now to find out variance, what you will have to do is you will have to find out ex square. So you will have to square all the values. So you'll have to find out x square. So x square will be 1, 4, 9, 16, 25, 36. And then you will have to multiply x square into px and then add it up. When you would do that, you will get ex square. And minus, then you already have mu, so minus 2.85 whole square. When you do, you can fetch your variance, and variance will turn out to be, ex square will turn out to be 11.35 minus 2.85 whole square will give you 3 point will give you 3.2275. Now, this value that you have attained, 3.2275, is the same value that you would attain by trying to find out the expected value of x minus mu whole square. For that, what you would have done? You would have again created this table and figured out your mu. And after figuring out your mu, you would have done 1 minus 2.85 square, then 2 minus 2.85 square, so on and so forth, and added that up. That would have given you the same result. So 3.22 is the answer that you will get for this question. For any random variable, when you're given the distribution, find out mu, find out ex square, and you will be able to find the variance. Variance is very important part of inferential statistics actually, because which just mean you will never be able to describe your data, describe your random variable or distribution that well. You would require variance as well in order to describe the distribution. This is what I wanted to discuss today. Thank you very much.